אוקיי, אז נראה לי שאנחנו ככה נתחיל ונכבד את כל מי שהגיע בזמן. אז קודם כל, ברוכים הבאים. אני מור אלדן, אני מנהלת את חברת מרקטק שפועלת בעולמות של מדיה וטכנולוגיה, ורובכם מכירים אותנו בוודאי בשם Israelclouds. וברוכים הבאים לפורום נוסף של FinOps. היום בעצם נדבר על אסטרטגיות לביצוע של right sizing, ונתחיל עם הרצאה משותפת של אסף עזרא מגרנולייט ואלי זילברשטיין מ-AppsFlyer. ומיד אחר כך יהיה לנו פאנל מאוד מאוד מעניין, אז אני ממליצה לכולם להישאר. ואסף, הבמה שלך.
So, thank you, Mo, and welcome everybody. We'll do this in English for the benefit of few attendees who asked for it. So we'll talk today about the journey of AppsFlyer to save about 30% on their costs with no cost code changes, as you can see. We'll talk about Spark Hadoop and Kafka clusters. I'll introduce ourselves. First of all, I'm Asaf. I'm one of the co-founders of Granulate and CEO of the company. With me, I have Ellie, Platform Group Team Lead at AppsFlyer. And Ellie,
hello, my name is Eli. I lead the cloud platform team in AppsFlyer. Today, we're going to talk about our journey with Granulate. But before we go any further, a few words about AppsFlyer. We are the global leader in the mobile attribution and marketing analytics. We have more than 1,000 employees with more than 400 engineers and 18 offices worldwide. On a daily basis, we manage about 85 billion events. And this is just an average number because in some peak time, we can even manage up to 120 billion events per day. Next slide. As you can imagine, we have a huge infrastructure, and you can imagine our cloud costs. We manage about 20 petabytes of data. We have about 20,000 of servers in our cloud infrastructure. The company is cloud native from day one, from the day it was founded, and we run in 3 major clouds, in AWS, in GCP, and also in Ali. We were constantly looking into our cloud cost and tried to be ahead of the curve. And we tried to adopt new technology as soon as it was released. And we are heavy users of the Spot instances from the beginning, once the feature was released to AWS. Now, 75% of our infrastructure is running on Spots. But we're also constantly looking into optimizing the cloud cost and the infrastructure. We use auto-scaling, we use the most optimized instance type, and we're constantly looking at all the cloud cost. And we try to find the solution, something out of the box, something that will allow us to be ahead of the curve and introduce more savings to our cloud cost. And then we run into Granulate. I will let Asaf say a few words about Granulate.
thank you, Ellie. So just a general notion about Granulate. Granulate's a real-time continuous optimization solution. Basically, we want to help companies handle their workloads with anywhere between 20 and all the way up to 80% performance improvements. The emphasis is on performance improvements, but we'll show you how you can take that into cost reduction as well with high percentages. Just as a general explanation, the premise behind Granulate is that everyone in production is using Linux or Windows. We operate on Linux only. And the operating system and kernel were built for a user behind the keyboard in mind, for interactivity, fairness, and so on. So we're doing a lot of things simultaneously. Everything's very reactive. Everything's very, very smooth. But it's not necessarily what we want to optimize for when we look at production instances. Because when we measure the performance of production instances, we measure latency, we measure IOPS, throughput, network throughput, and so on. So we'll give an example as to how it works and why it's important to make the kernel operating application aware. This is an example of microservice-based architecture, but it's also true for anything that's I/O operation. So let's assume that we have a single server on service A right here. And that service is handling an API request. This could be, for example, a login request. Netflix says that for each login request that it receives, it generates about 250 requests on the downstream at the backend. So this is not to just verify the user. It's also to query his history, give him some recommendations, what's new, continue watching, and so on. Now, these are independent, so they're all happening at the same time. But some of them are going to return a response faster than others. For example, if I just signed up yesterday, probably querying my history is faster than other things that are being done in the backend. For example, what's trending and so on. And from the kernel and operating systems perspective, we right now have a file descriptor ready. We have data ready to be processed. So if we're being polled or a thread is sleeping on the file descriptor, it's going to be waking up and we're going to try and process data as fast as we can. However, from the application perspective, for this particular request, we'll still be waiting on other services that are that should return a response at a later time. And so we're not necessarily hastening the response generation, while other requests, other login requests that we have in the system are waiting to be accepted and sent to all these services in the backend, or other data from these services coming back to service A and going back to the user. So basically, when we choose to process the data as fast as possible, we may delay other requests. Now, this all changes once services X and Y, Y and Z, sorry, have returned a response, because right now we can generate a response back to the user and maybe free up some resources. But once again, we're at the mercy of the operating system and kernel, or the application if it was built to prioritize between these things in the manner of if we choose to actively process these as fast as we can, or maybe some other data that's in the file descriptors for other requests or other requests coming in. So we create contention on the resources if we don't prioritize correctly. Now, Granulate solves that by, first of all, automatically learning and analyzing the data flow, the data flow that we've seen. So we accept an incoming request, we may be going to the disk, to the network, and so on. And then Granulate hooks into all the resources that could be contented, whether it's the CPU, network, disk, mutexes, atomic operations, and so on, and reprioritize everything to optimize the performance that we're looking for, whether it's latency, response time, throughput, whatnot. Now, since we increase throughput, reduce the latency, and so on, we can abide by the same SLAs with much less compute resources, as we'll explain going forward. And obviously, this is a continuous process. As we mentioned, it's a continuous optimization solution, since everything is happening over and over, because traffic characteristics change throughout the day or between weeks. We can deploy new versions, and we want to make sure that we're still relevant, and so on. Now, as Ellie explained, the challenge with a system like AppsFlyer is that it's already well optimized. It contains a huge amount of services. So if you want to re-architect something, if you want to change the code, it requires a lot of effort. So it fits right into where Granulate optimizes, because no code changes are required. You can start with a single VM. Each service is optimized on its own. And so even though there's massive infrastructure, there's massive amount of services, different instance types, and so on, Granulate can help reduce all of that without harming the velocity of the R&D efforts.
At the beginning, we were very skeptical about the solution. It was too good to be true, but still we decided to do PLC. And we defined our PLC goals as following. We wanted to make sure that by using the solution, we will have a cost saving as expected. And since we're talking about the SaaS solution, we wanted to make sure that we keep our data private, that there is no privacy issue, that we don't breach our customers' data. And also, we wanted to make sure that there is no negative impact on our infrastructure, on our services, once we deploy the agent. Next slide, please. Okay. So the first service that we chose for the POC was a Hadoop Spark cluster, self-managed Hadoop Spark cluster, which is running on 300 R4 2 extra large services with the CPU utilization of 70% with the cyclic load patterns. If you're familiar with the cloud cost, you can imagine cost of running such cluster. Once we deploy the Granulate agent, we activate the agent. we saw 25 reduction in the CPU utilization and also significant reduction in job completed time. As you can see from the slide, once Granulate agent was enabled, this is the real graph from our real monitor visibility system. The CPU dropped by 25%. We ran it with Granulate for a few days, and then since the CPU was much lower, we could downscale the cluster from 300 nodes to 200 nodes, and then, as expected, the CPU went up, but we could reduce the cluster by 30%, and this is a very good result. Next slide, please. And second service that we tested was one of our Kafka consumer services, which were performing heavy compute logic. The cluster was built of 500, depends because the cluster have auto scaling, but on average it had the 500 mixture of C5, M4, and M5 machines with an average CPU of 75% usage. The cluster was using auto scaling based on the Kafka leg. And the service was a CPU bound. Next slide, please. As you can see, once we deployed the Granulate agent, the picture from the CPU point of view changed. There was a 30%, immediately 30% reduction in CPU utilization. And also we could have an improved throughput and processing time. This allows us to reduce the cluster size by 35% and basically achieve a 35% cost reduction of the cluster. Next slide. And I will let Asaf explain about this magical solution.
Thank you, Ali. So as you can see, everything's pretty fast, and you can see here the whole timeline for the entire process. We start on day one with an agent installation. It could be a single command line. It could be a chef cookbook. And with less than 5 minutes, you can have an agent running on 1 to 2 to 4 VMs. By day 5, after the autonomous analysis that we talked about, you can already start activating the agents, as we've seen with the CPU graph for the Hadoop cluster. And then we can do a 1 to 2 weeks comparison before and after or side by side, and move to a full cluster deployment and start enjoying the reduction benefits. This could sometimes come with complementary changes to auto scaling metrics. Just because you need less compute, you can sometimes reduce the requirements, whether it's for containers or the size of the machine itself.
So what next for AppsFlyer and Granulate? Immediately after the successful POC, we applied the solution in our 4 additional Kafka consumer services, which were running about 600 EC2 instances. Those clusters were fully optimized by Granulate without any side effects, and we could achieve additional 30 to 35% cluster cost reduction. Next slide. And now we plan to integrate Granulate into AppsFlyer provision system, basically to enable Granulate by default for every compute workload, and to allow any service owner, any engineer to enable Granulate agents on his service, and basically to continue expanding and optimize our infrastructure to achieve additional cost saving. Next slide. I will let Asaf do the summary.
So in summary, as you can see, Granulate in general just requires a Linux server, so it's pretty much agnostic to the architecture. This could be bare metal, cloud, multi-cloud, Kubernetes, and so on. It's an agent installation, so we can start with a single command line. I'll demonstrate that as we go. And anywhere between 2 to 4 VMs are required for the beginning. It's agnostic to the other initiatives. As Ali mentioned, their system is very well optimized. They started with a huge amount of spot instances, and everyone would like to, or most organizations would like to reduce the amount of instances that they use, regardless of being spot or not. And it's also true for right sizing. As we mentioned, if you've done right sizing, you install Granulate, you might need to reduce the size even further, or able to. All with no R&D efforts. And I'll do the demonstration, and then we can move to the Q&A. So for the demonstration purposes, we have here the Grafana. As you can see, it's sort of a, it resembles the monitoring solution for organizations. What we can see is that we have 5 machines right here. Behind each machine, there are 10 machines in the backend. And as you can see, it's this connection-based load balancing based on ELB. You can see that they're doing roughly 120 requests per second each, with 2 being slightly further, but overall pretty much the same. In terms of the latency, we can see that machines are doing roughly between 44 to 52 milliseconds 90th percentile, meaning 90% fastest requests are responded to within, let's say, the worst case, 57 milliseconds in this case. Median latency is even closer apart, so 31 to 34 milliseconds, so 50% fastest requests. And CPU utilization is sort of quite well, around 60-something%. And what we like to do is we like to show that when you install Granulate, what you can expect. Because from an organization perspective, this might look like a very optimal service. And so I'm going to log into one of these. Oh, sorry about that. And so that's 128, which is a green one. So that's good. It's it looked like the worst one, and we'll see what happens when we install Granulate. Basically, as we can see, in this case, it's simply inserting Granulate kernel module, currently optimized for latency on port 80, which is the port where this server is listening. What we can see is that with no downtime, no deployment, and definitely no code changes, the machine starts to act a lot faster. So it's going to take on a higher load. As we mentioned, it's least connection based. We can really see it on the median latency. So we went down to about 23 from where the green machine was around 33 milliseconds. So that's almost 33%. What we can see in the 90th percentile, we went down to about 40 milliseconds, whereas the machine was at about 52, 57 sometimes. And the machine is doing a lot more requests per second. Now, as a customer, I can ask myself, what do I benefit from that? If I'm looking for cost reduction, obviously the machine is at a much higher throughput, so I can reduce the cluster size, handle the same load with less compute. Or I'm looking for the better performance, so I'm going to install Granulate on the rest of these services, the rest of these machines. What I'm going to do now is simply uninstall Granulate, and what we can see is that immediately everything will go back to the way it were, because basically the way that it happens is that we change the decisions as to which thread is getting the CPU, or which thread is getting locks, or which socket is being processed first, and everything will go back to the way it's normally done. So what we'll see is everything going back to the way it were before. That's pretty much it. And I'll open it now for questions. So I have a couple of questions here for me, Ali. Stop sharing so we can go back to seeing everyone. What kind of metrics data does Granulate retrieves to determine which service is prior to another? Well, Granulate does not prioritize between services. What Granulate does is optimizing the process for which the user selects Granulate to optimize. This could be a single service in Kubernetes. This could be, if we're talking about a shared environment, for example, where we have multiple containers on the same machine. And the machine itself is responsible for prioritizing between different processes. It was built for interactivity, so it's really good at that. And so, as you've seen, in this case, we chose a certain port. Whatever was listening on that port, that was what we optimized for. Does this solution depend on the platform? Does it support Golang, Python 2? We support C, C++, Python, Golang, JVM-based languages, so Java, Scala, Clojure, Node, Ruby. I think these are the ones that we currently support. In kernel versions, anywhere between 3.10 and all the way up to 5.3. The agent is installed on the host, yes. So it's installed on EC2 instances. If we're running EKS over EC2, for example, that's an option. Not directly on the container. When the Java process goes up, it takes all the memory from the servers. So how do you deal with that? Basically, we don't aim to disrupt the memory or reduce the amount of memory that the Java process is using, but we will definitely reduce the amount of garbage collection that you see and probably the amount of memory that is actually being used. So maybe you'll be able to reduce that amount going forward. In the case of what we've seen with Hadoop is obviously you have certain jobs running for a certain amount of time. If you can shut down your machines after a shorter amount of time, you can also reduce the costs without actually reducing the amount of resources that you use. What is the overhead cost of deploying Granulate agent? So while it's analyzing everything, Granulate is actively blocking the agent from taking over more over 0.1% CPU and 22 megabytes of RAM. The idea is to lengthen the analysis process on the expense of the amount of the overhead, because we would prefer not to harm anything. I think Ellie mentioned that was one of the goals of the POC, to see that Granulate does not harm anything as we move forward. So we actively maintain that. What's the purpose of the Spark cluster? What kind of jobs it does? Does it affect the efficiency of Granulate? Ellie, do you want to take the?
Yes, we tested on the Spark cluster. That is the purpose of it is the streaming of data, and I think the purpose of the cluster does depend on for the Granulate. So
yeah. As Ellie mentioned, it doesn't affect, we have other customers with Spark clusters and we see very similar results. Sometimes it goes all the way up to 50%. That actually depends on the job itself. But since Granulate is oblivious to how the job was written or what it does, I will not be able to tell you. Does Granulate work on other cloud providers or on-prem? Yeah, Granulate has an on-prem based installations. We have a few financial services. They care a lot about the data. So we had to give them an on-prem installation. And in terms of cloud providers, we work on AWS, Azure, GCP, and so on. How does the agent work when a host has different pods, when each pod might do a different thing? Okay, so this goes back to the question about how Granulate operates. So Granulate operates on the process level, not necessarily on an application level. So if you choose each pod from, for example, different services, then you'll have to state which services you want Granulate to optimize. So which pods eventually will get optimized. And the reason being, the idea behind Granulate would be to say, we understand how the data flows from a certain process perspective. We don't necessarily understand the entirety of the different processes. And so we'll start with a single service. You'll see that from the metrics of those pods or that service, things are improving. And then you might move on to the other services. Not necessarily start with the entire node at the same time. Is it a SaaS service or it can be installed offline? Yeah, so it could also be installed offline, as I mentioned, with the financial services. Does it provide the same benefits? Well, that depends. Obviously, incremental version upgrades will have to be done manually. And obviously, if we have some research to do and we are looking for some things that are common between different customers, then it'll be hard to take into account the things that are in the offline installation. So from a direct perspective, maybe not, but definitely it'll change the amount of priority we can give that customer's specific changes. Does Granulate work on Red Hat and other commercial Linux? Yeah, it does not void warranty. As you can see, everything's volatile with Granulate. So even if you are required to uninstall it, and I demonstrated how you can do that very easily, you could do that for the support purposes, but we are a technology partner of Red Hat for that exact purpose. And also for with VMware. The reason being exactly as you asked, we don't want to void the warranty. We want to make sure that we comply, and we want to make sure that our customers are happy with the service. But if not, definitely feel free to uninstall. Everything's volatile. Ellie, question for you. How easy was the installation?
The installation was very simple. In the beginning, we used just a simple shell script to deploy the agent, and now we use configuration management. We use Chef Cookbook to deploy it where we need. So it's a very simple process to deploy it, also to uninstall, and I think you showed it in the demo, where anyone can integrate it in the system. I think there was another question if you need to install it on the machine or on the container itself, and the answer is that you need to install it on the machine, not on the container. And maybe you can explain the reason behind it.
So the reason is very similar to Kubernetes. Basically, Granulate look at it from a process perspective, and each container is usually responsible for one or more processes, and from the kernel's perspective, everything looks the same, only with maybe namespaces that are limited in the amount of resources that they can take. Granulate abides by those limitations if needed. Okay, so that was the last of our questions, and thank you for listening, and we'll give the microphone back to Mo.
Thank you.